Hello, everyone. Thank you for joining us today for the business case for MLOps. Quick introductions. My name is Emily. I'm joined by my colleague Sarah, and we are both data and analytics consultants at Thorogood. I've put our contact information on the screen, and that's intentional. Please reach out if you have any questions throughout the webcast. Quick agenda for today's webcast. We'll start with an introduction to Thorogood, and then we'll move on to the enablers of ML. From there, we're going to specifically define what MLOps is. And then once we have that foundation, we'll move on to the benefits of MLOps. And we'll conclude with some advice on how to get started and some next steps. All right, so we'll start with a quick introduction to Thorogood. Who are we? What do we do? Big picture, we help our customers make sense of and find value in their data. We're an independent and specialist data and analytics company with a focus on data engineering, data science, and data visualization. Our approach is rooted in understanding business goals and using the capabilities of technology to meet these goals. So customers and business objectives are always at the forefront of what we do. We are a global company with offices and consultants in Asia, Europe, and the Americas. Sarah and I are both based out of our Philadelphia office. And we offer a full range of services when it comes to data and analytics. That includes data and technology strategies and roadmaps, end-to-end implementation of cloud solutions, user empowerment, analytics services, and so on. Our customers are typically multinational blue chip organizations. I have a few listed on the screen. Most of our clients fall into one of four verticals: consumer goods, pharma and life sciences, financial services, or insurance. These industries are just innately very data rich, but we're certainly not limited to these four verticals. We are an independent consultancy. We're not tied to one specific technology. Instead, we stay on the forefront of technical possibilities through partnerships with the companies that are providing really the world-leading business intelligence and analytics tools. The business case for MLOps is the first of a three-part webcast series that we've designed to introduce and provide insight and practical advice pertaining to MLOps. So the intent of this session is to position the business value of MLOps, and the subsequent sessions will take it from the business case to more practical and tangible steps for implementation and adoption. Before we get into MLOps, let's start by taking a moment to put this in context. So why are we talking about this, and why now? Well, first we need to understand that conditions in the world have changed, and these changing conditions have made machine learning more important and will continue to make it more important. So what exactly is enabling advanced analytics and ML? So we have technological advances, so smartphones, the Internet of Things, coupled with changing consumer behavior has resulted in this proliferation of data. And then we have advances in cloud computing, which have made storing and processing that data cheaper and easier than ever. With that, we have the availability of open source libraries, so Prophet, TensorFlow, Keras, to name a few, and the evolution of analytics tools that have made it possible to apply statistical techniques in new ways and at a scale that was previously very inaccessible for most businesses. As these conditions have acted as enablers, we've seen many companies invest heavily in AI and ML to see if they can find value that was previously pretty hard to uncover. A study that MIT Sloan did with BCG found that 71% of respondents felt that they understood how AI would change the way their business generates value. But only 11% reported actually seeing significant benefit. So people are recognizing where the value exists, but they've not yet gotten to the point where they can fully see and realize that benefit. So why is that number, that 11%, why is that so low? And why is there this significant gap there? That gap between investment and realized benefit is caused in large part by the inability of most companies to shift from experimentation to a productionized state. So we're seeing businesses invest in experimentation, so exploratory ad hoc analytics done in sandbox environments, which are often local and non-integrated. And this is great, this is necessary. Rapid experimentation is a key indicator of a healthy, robust, and dynamic analytics-driven organization. But where we're losing out on our investment is the inability to operationalize those experiments to something that is enterprise ready and robust enough to affect change. And the reason for this, that there are fundamental differences in the needs for experimentation, so flexibility and tooling, specific skill set, and the operationalization of ML solutions. And it's important to understand, and I want to emphasize that these are not two discrete things or states. What we're leading to here and what we're building to is MLOps. When we set up an MLOps framework, we're actually doing our experimentation within an operationalized system. But what exactly does that look like, and what does that really mean? Let's break down the typical MLOps project lifecycle to give this a bit more color. So we'll start with this phase one, so define. This is when we understand our business needs and define a viable POC. So examples of this could be, we want to simplify product portfolio from the lens of sales volume. Or maybe we want to understand how innovation is performing and look to detect potential opportunities in growing segments. So that's phase one. The second phase, we have experimentation. This is where cleansing, normalizing, imputing, and feature engineering and selection with input data, this is where all of that occurs. So we prototype and experiment with modeling approaches and evaluate results. The output of this phase is a trained model that is suitable for productionizing. And just a note here, not all experiments end up going to production. And then this third phase, we have industrialization. So here we productionize all CI/CD components needed for the model to train and score at scale. So data engineering, data science, data visualization. Here we would refactor experimental code for scalability and create automated CI/CD ML pipelines. We also develop and test automated model monitoring capabilities here. And then this final phase, phase four, monitor and improve. Here we perform ongoing monitoring of the ML system and model performance to stay ahead of any drift or model decay. This phase is important for gathering feedback from end users as well to continuously test and integrate improvements. The critical component here, or I should say one of the critical components, is it's that our experimentation is really embedded or ingrained in our productionized lifecycle. So again, it's not a discrete state from that operationalization. Before we continue too much further, let's take a minute to more explicitly define MLOps and how it relates to the perhaps more familiar DevOps. So DevOps is a set of practices that combines software development and IT operations. It aims to shorten the system development lifecycle and provide continuous delivery with high software quality. DevOps is probably a more familiar term. And then we have machine learning operations, or MLOps, which refers to practices for orchestrating the industrialization, deployment, and maintenance of machine learning models in a scalable and standardized way. Just to kind of go a little bit more in depth here, some similarities between the two, MLOps and DevOps: continuous integration of source control, unit testing, integration testing, and the continuous delivery of the software module or the package. But we do also have some key differences that are pretty important to highlight. The first being skills. The skills of an ML engineer are different from software engineers or DevOps engineers. So apart from usual software engineering skills, an ML engineer needs to have experience in statistics, model development, and monitoring. And then testing. Testing a machine learning system goes beyond the typical unit and integration testing. You also need to consider things like data checks, model drift, evaluating model performance. And then we have data. ML models can have reduced performance not only due to suboptimal coding, but also due to constantly evolving data profiles. So in other words, models can decay in more ways than conventional software systems. And you really need to consider this degradation. Therefore, you need to track summary statistics of your data and monitor the online performance of your model to send notifications or rollback when values deviate from your expectations. More points of failure. In MLOps, you may not necessarily be deploying just a model artifact. Deployment of a machine learning system can require a machine learning pipeline that involves data extraction, data processing, feature engineering, model training, and model deployment. Versioning. Apart from code versioning, MLOps needs to keep track of dataset versions, model versions, and the hyperparameters used in the training. And then finally, in MLOps, there's a third concept that doesn't really exist in DevOps, which is continuous training. This step is all about automatically identifying scenarios or events that require a model to be retrained and redeployed into production. This could be due to a performance degradation in the currently deployed machine learning model or system. All right, at this point, I'm going to hand it over to Sarah to walk us through some of the key benefits of MLOps. So Sarah, I'll hand it over to you.
So I'm now going to walk you through the 4 key benefits of MLOps that we see as bringing the most value to the business. So the first here is increased accuracy, trust, and awareness. The second is empowerment of data scientists. The third is the ability to uncover value quickly. And the fourth is the ability to manage costs. So let's back up for a minute. Why are we using machine learning? Why do we have data scientists and entire divisions dedicated to advanced analytics? Well, nowadays, this is how the businesses will make decisions, prepare, and adapt. And generally, we understand how this works. We have data. This is either going to be our own internal data or we paid a third party to provide us with this data. Then we send the data into the black box of ML, and out comes forecasts, predictions, and essentially guidance on how and what to do. This is a little bit of a problem. Business users who are used to having visibility into their information that they're being given might need some more convincing than that. And that's fair. These decisions aren't exactly trivial. It's reasonable to question the models and forecasts that algorithms are producing. And I think that as a society, we're generally starting to trust that black box a little bit more. So for example, when Amazon makes a recommendation for you, there's no one over at Amazon approving that recommendation. But again, with some higher stakes business decisions, we need to provide a little bit more trust in what we're producing and what we're seeing. Not only that, but there's a bit of an ethical component to this as well. If we're basing decisions off of models that are affected by data drift, then that could be an issue. And this is where MLOps proves to be extremely beneficial. When we implement MLOps properly, we're building in a framework of auditability, monitoring, and responsiveness. Essentially, we're providing a little bit of transparency and insight into that black box. We can monitor the data for drift, we can monitor our models for degradation, and we're keeping a pulse of the health of our ML algorithms and really that entire life cycle. The ability to monitor is really a means to respond to data changes, to respond to model degradation, to respond to changes in business problems. We want the ability to evolve the model to incorporate anything that's happening, and we can only do that if we can really see what's going on. In this way, MLOps is an immense benefit to the business because it's increasing the accuracy of and our trust in ML models. And on top of that, it's giving us the opportunity to respond and evolve. An MLOps framework will also directly impact data scientists by providing them with the ability to apply their skills in other areas and solve some of the problems that they face with enterprise machine learning. One of the many activities that data scientists are responsible for is the development and productionization of models. After deploying a model, it is very common for these data scientists to oversee model performance and provide ongoing monitoring and maintenance. They also do things like gather feedback and implement changes, and then test and redeploy the models. In order to ensure accuracy and reliability, this must be an ongoing cycle. This process may be manageable for a single model or two, but more often than not, there will need to be many models for different subsets of data, and as the amount of models increases, the overhead of this process becomes entirely too much for someone to manage, and all of their time becomes focused on these activities, leaving them with little to no time to focus on other responsibilities like collaborating with other areas of the business or adding new features to existing models and focusing on innovation and bringing their skills to other parts of the business. Incorporating an MLOps framework and architecture that supports enterprise scale machine learning allows for the automation of these processes that were once a huge overhead for data scientists. This will empower data scientists to perform even more valuable analyses by using tools that support greater scale, faster processing, and wider functionality, and also spend their time instead on adding new features to existing models and innovating to solve other business challenges. For example, when working with a data engineer, data scientists' models with long runtimes could be re-engineered to take advantage of an enterprise architecture that enables greater parallelization options, allowing for strands of the model to be run simultaneously and processing times to be dramatically reduced. Automation here also presents quite a few other benefits to the business. Automating the support and monitoring process reduces the risk of manual or human error and also presents the opportunity for scalability across your organization. By applying this automation to models, you can fit and tune across tons of different cuts of data, which would have really never been possible for just one person to do. An MLOps framework is critical for empowering data scientists to apply their skills in the correct places and not be wasting their time focused on auditing and maintenance. To get to this point, you'll need to ensure that you have the proper tools and governance in place to allow for success within your framework. Incorporating tools that provide better tracking of experiments can provide data scientists with more robust environments for model building, training, and testing. And alignment on MLOps standards allows for simpler training and spending of best practices, both among data scientists and MLOps teams. Empowering data scientists to perform their experiments in enterprise environments and providing them with the guidance on best practices for scaling can equip them with more powerful tools and a faster path for deploying models to the business. One of the next key benefits of an MLOps framework is the speed in which value can be realized and ultimately used to make decisions by the business. It's clear that the manual activities that are done by data scientists take a considerable amount of time that could be better spent on innovation and improvements to ML models elsewhere. There is, however, another side to this coin, and that is the time lost by business users to use the model outputs to inform business decisions. Had this experiment been productionized with MLOps principles in mind through its inception, model outputs would have inherently been more valuable due to predictions being coupled with great speed. It's probably easiest to see this value demonstrated through an example that we have seen firsthand at one of our clients. This particular client had a trove of manual activities that were required to refresh model outputs due to the nature of how the experiment was designed up in its data preparation, data modeling, and model generating steps. So much manual effort, in fact, that at the beginning of every month, it took roughly 7 days to actually refresh the model outputs so that they were interpretable by the business. Obviously, this effort takes a toll on data scientists, but it also affects the business too, as it takes them quite a long time at the beginning of every month to get their hands on the model outputs. When Thoroughbred worked with this particular client, bringing forth this ML experiment into an MLOps framework, the model outputs could be received by the appropriate business stakeholders on day 1 of the month rather than day 7. This week of extra time gave stakeholders more time to interpret and formulate analytically based decisions on the same model outputs, but so much sooner. From a competitive standpoint, this additional week of time is critical when it comes to competition. If an organization can drive insights quicker, particularly from an analytical perspective, then that organization can beat competition that may be slower at reaching that same insight. This additional time could ultimately be the difference between a winning strategy and a losing strategy in the market. And finally, the management of costs. Costs are at the forefront of everyone's mind. With a proper MLOps framework implemented, traditionally expensive solutions can be minimized through things with sound cloud infrastructure principles, cutting down on compute costs through parallelization and optimization, and improved data management principles in handling of tech debt. It's nearly given in today's day and age, but to have your ML experiments developed and subsequently productionized in a cloud-native environment is key in unlocking their true scale and value. However, despite an enterprise cloud environment truly enabling the success of a productionized ML solution, it is increasingly important to ensure that there is a sound cloud cost management when it comes to actually supporting them. ML solutions are compute heavy. Odds are that they are coupling many different data sources together in the magnitude of millions of records and subsequently generating an ingestible outcome for the business. There are technical aspects that should be considered when productionizing an ML experiment within a defined MLOps framework, like the parallelizing of your model's workloads or refactoring the code to be more performant that can cut down on the overall run costs of running a model. We'll expand on this concept a bit more in an upcoming webinar, Implementing MLOps, which is taking place next week, for a couple of strategies that we've seen success in, but the strategy still stands. Having a performant code so that the resources are being consumed appropriately is a key benefit of operationalizing an ML experiment within a defined MLOps framework. A hidden cost that is familiar with those working within traditional software engineering projects, tech debt, is something that may be managed appropriately and can be done so with the help of a defined MLOps framework. Without careful consideration in the experimentation stage, seemingly hidden maintenance costs can manifest themselves in ways that can compromise the value returned by an ML experiment. Some examples could be something like changes in master data that are driving outputs, redundant or inefficient data engineering pipelines, or even the difficult to quantify manual efforts that should be replaced by automation. It's not feasible to measure every piece of debt that is to be incurred by an ML project over its lifespan, but to mitigate as much as possible in the development stage through a defined MLOps framework will make paying off much cheaper in the long run. So we explained the 4 key ways that an MLOps framework can bring value to your business. You may still be wondering how to get started. At Thoroughgood, we have experience in strategizing and implementing MLOps frameworks at the organizational level. From a more assessment level perspective, it's really important to understand where your organization and all of its ML applications and experiments stand from a maturity perspective. Having a baseline of where your organization stands from an MLOps perspective is obviously the best place to start. And upon gaining understanding through a readiness assessment, it makes sense to subsequently strategize next steps and implement some of the more technical aspects that we've discussed in this webinar. If you're interested in learning more about how Thoroughgood can help implement an MLOps framework within your organization, please feel free to reach out to Emily or I, and we'd be happy to discuss with you. Additionally, a few consultants from Thoroughgood recently presented a session at Databricks Data and AI conference last month. The session was based on our learnings from developing MLOps strategies for enterprise customers, specifically focused on our learnings from a CPG engagement where we tested a framework by implementing MLOps industrialization and ongoing monitoring and support of models. If you're interested in this session, you can find the recording on the Data and AI Summit's website or reach out to us at Thoroughgood if you'd like more information. And as Emily mentioned before, this is the first of a 3-part webinar series focused on the lifecycle of MLOps. The second, Implementing MLOps, will be coming up on June 22nd and is focused on more tangible steps to implement an MLOps strategy. And then the third, Managing Successful Adoption of MLOps, is on July 8th, and we'll cover the strategies and practices to managing an MLOps framework after implementation. You can register for these events on our website, which is shown on the screen below. Thanks again for joining our webcast today, and if you have any questions, please feel free to reach out to Emily or I, and we'd be happy to chat with you.